Hello, everybody. Thank you very much for joining, and welcome to Locogen's webinar on repowering onshore wind in Scotland. Over the next just under an hour, we will be discussing the technical, commercial, and planning considerations and guidance that should be accounted for when it comes to repowering wind projects in Scotland. Hopefully, we can provide you guys with some insights from our works to date and a few key takeaways to think about going forward. So yeah, my name is Ian McLean, and I'll be your main presenter today. I'm an associate director at Locogen, and my role generally involves leading the wind advisory team. The advisory team, we get involved in projects across their development lifecycle with a lot of early stage development works at the original project inception, and we stay involved projects through consenting, construction, and on into operational stages where we provide support for Locogen's asset management team. I've been working in renewables for around 19 years, and 14 of which have been at Locogen. And joining me is Ewan Hutchison. Ewan, do you want to give a quick intro to yourself?
Yeah, thanks, Ian. Hi, everybody. I'm Ewan Hutchison. I'm the Planning Environment Associate Director here at Locogen. I've been here for just over 3 years now, and scarily have been around doing this sort of stuff for 30 years. One of the first wind farms that I ever worked on when I started my career with Dumfries and Galloway Council is currently in planning for repowering. So um, yeah, sobering thought, but hopefully we can bring some of that experience to this webinar today.
That's great. Thanks, Ewan. So this is a rough outline for the rest of the webinar. We've divided it into 4 sessions with time for hopefully a reasonable Q&A session at the end. If you do have any questions on anything we've covered, then you can post them by clicking on the question mark in the top right-hand corner of the screen at any time during the presentations. As I say, we'll hopefully get a chance to answer them at the end. But if we don't get round to all the questions within the hour, then we will try and respond in writing and are happy to share those responses with all attendees. Okay, so on with the presentations. My role at the start is to run through the main technical and commercial repowering considerations and challenges that we've come across to date, which includes grid, available space for development, access, and property. At Locogen, we're actively working on around 7 or 8 repowering projects just now on behalf of our clients. And this is across a range of scales from single turbines up to mid-sized wind farms of 20 megawatts in capacity at the moment. As Locogen are involved in every stage of the wind development process, we do feel that we are very well positioned to provide a holistic take on repowering options and setting out the best way forward that balances the technical, commercial, and planning risks that these projects face. So headline figures very quickly, just over 15 gigawatts of installed onshore wind across the UK, with around 2/3 of this capacity in Scotland. As shown in the summary figures and the graph, a significant number of wind farms will be reaching 20 years of operation in the near future. It's generally well accepted that repowering will hopefully make best use of our available onshore wind and land resource as well as the available grid infrastructure. And without a substantial amount of repowering coming through, we are going to see a drop off in performance and total output of our onshore wind portfolio as these original wind farms continue to age and are potentially decommissioned. Once we also consider development timescales, which even for a repowering project is still likely to be 2 to 4 years, definitely see the benefit in starting now to identify the best option to take forward for a given site, so that we can start that planning process and engage with all the right stakeholders in good time. As mentioned, Locogen have a range of clients that we're currently progressing with repowering works. And these are generally split into 2 groups. We've got the feed-in tariff project owners, generally comprised of single turbines, and many are looking at early repowering after only 10 to 12 years of operation on the basis that they're still able to hold on to their FIT incentive even after replacing the turbine. This is typically being driven by poor performing turbines, but there is also an opportunity to put in a larger turbine with a capped capacity to maximize the generation and resulting returns for the remaining feed-in tariff incentive period. And there's currently around about 300 megawatts of installed feed-in tariff wind turbines in Scotland. The next group, which is probably primarily the sort of scale that we're focusing on today, is looking at renewable obligation accredited wind farms. They comprise the majority of the remaining installed capacity in Scotland. They don't have the option to repower and retain their accreditation, so early repowering before the end of their 20-year accreditation period would typically only be advisable in the event of significant faults or underperformance from the existing turbines. So what are the drivers for repowering? I think, yes, there is life extension, which is really important, and being able to get the best out of the turbines, many of which, if they're well maintained, can work well beyond their 20-year design life. However, a number of operational sites that we do assess struggle in terms of their performance in later years. Early turbine designs have not always aged well, and many have required major component replacement works, which are expensive and can lead to a significant drop in availability, as demonstrated by the shown graph. Pushing these turbines beyond their 20-year design life, does require a good O&M provider and proactive maintenance and replacement regime. But in the absence of subsidies post-accreditation and with higher operational costs, the profitability from extending these original wind farms can become marginal. So repowering with larger scale turbines can achieve a significant increase in yield. So even if the capacity is not increasing, the site can produce a lot more renewable power, especially if we can utilize modern large scale turbines of 4 or 5 plus megawatts in capacity. If we factor in this potentially significant bump in generation alongside the much reduced per megawatt maintenance costs and then potentially a new 25-year design life, then there can be a strong business case for repowering. There may, however, be one or more major constraints, which means that the projects need to look at repowering with turbines either similar to the original scale installed or a midpoint between the original installation and what would be a new modern large-scale turbine. These alternative turbine options would most likely be reconditioned, as most manufacturers are now focusing on the 150 meter plus 4 megawatt plus capacity market. So these are probably the three different options we see here. Is a potential for a like for like replacement if there is a hard constraint that stops you looking at larger turbines, and then a mid-sized option, and then a large scale option as well. So just some initial thoughts on business case. Now, doing the business case for any repowering project is complex, and it will depend on many different variables, such as the extent of existing infrastructure that can be reutilized and the achievable scale of development. Also, decommissioning and restoration costs come into play. Our works to date have highlighted that although the capital cost of repowering with reconditioned options, turbine options, can be favorable on a per megawatt basis, this does come with a significant bump in operational cost. And this, alongside the lower yield and shorter assumed operational life, typically means that reconditioned options will have higher overall levelized costs of electricity, when compared to modern large-scale turbines. No big surprise there. And as you can see, there is quite a difference across the three options considered in the table. Again, as no surprise, the available wind resource will play a big role in ascertaining what the most viable option or options are for the site. And based on the average Scottish wind resource, which we've sort of shown here, the levelized cost of electricity may make this project marginal. However, if we did look at a 10% bump in the available wind resource, so looking at a better wind resource site in the same project, we can see that there is a sizable drop in the LCOE, which certainly brings the new turbine option into a more competitive price bracket. So yeah, I'll now go through some of the key technical factors that will need to be assessed when exploring repowering. So every presentation about renewables these days invariably ends up with a big focus on grid, and really there's no surprise when you see that the existing network is bursting at the seams and that there is a very long queue for new connections which are dependent on multiple billions of pounds of investment. So with repowering, you would think that, well, there is that initial assumption that grid is not an issue. And yes, certainly repowering does present a key benefit in terms of having existing grid capacity available for use. However, there is still a reasonable amount of grid risk. And a lot of this does depend on what you need and what you are asking for. So yeah, it is the majority of sites up for repowering in the next while are likely to be distribution connected projects. So we'll kind of refer to connections on a distribution level at this stage. So the good news is that contracted generation is generally deemed by the Scottish DNOs to be evergreen. Some of the earliest connected wind projects, particularly those in SHEP-D area, did come with time-limited connection agreements, but we have challenged SSE on these, and they have said that subject to having all the necessary property agreements in place, these connections can continue to be used by wind farms going forward. So if you do have a time-limited connection agreement, that is not in itself shouldn't be a barrier for looking at repowering. And ultimately, yes, repowering is a potential easy yes for the DNO at a time when they're very used to saying no. So, but we have become unstuck in recent repowering projects when we get into requests for additional capacity and or co-location with other technologies, such as solar or storage that's looking to share the existing grid connections. Both of these requests can effectively put the project at the back of the connection queue, or at least the modifications to the back of the connection queue, as they are at least required to go through, almost certainly required to go through expensive and time-consuming transmission impact assessments, and as a worst case, may need to be sitting and waiting for reinforcements. So that is not to say that the project could not repower within its existing contracted capacity and technology type in the interim, but any uplift in capacity or addition of new technologies may, as a worst case, be waiting a number of years to be connected, which would then require a multi-stage development approach. Other areas to consider around grid relate to the other operational parameters within the connection agreements. So in Scotland in particular, and some places in England now, but a number of circuits and grid supply points have reached their allowable limits in relation to things such as fault levels. And so a repowering project may be required to work within the original limits set out in the connection agreements. For example, Scottish Power are particularly keen on this on some of their more highly constrained areas. So that's a consideration, particularly not so much of an issue, which shouldn't be so much of an issue for new turbines, but if you're looking at reconditioned turbines, that may become problematic in terms of what is allowable. Also, as well, that may be an issue when looking at potentially using reconditioned turbines is whether or not they can adhere to the G99 engineering recommendations. We've a number of sites that we've worked on where that has been an issue, and sometimes can lead to expensive retrofits and things such as statcoms or other equipment that allows the wind farm to comply. So that's definitely an important consideration. So let's move on to considering the space available for development. So when swapping out a larger number of smaller turbines for fewer larger turbines, initially it could be assumed that the footprint of development would allow for a good amount of space, as you're generally dealing with fewer turbines. But this is not typically what we've seen. We have a random 12 megawatt wind farm project, which we've used an example of what issues may arise in relation to available space and layouts for differing repowering options. The triangles on the map represent the existing turbine locations alongside some key spatial constraints. And first of all, to note is that the residential setbacks needed to limit visual and noise and shadow flicker amenity issues were historically smaller than what we would expect nowadays. Some of this might be down to limited guidance at the time of the original installation, but also would be down to the smaller scale of the turbines relative to what we're installing now, typically. We've also had a couple of sites where residential dwellings have been built closer to the wind farm since the original turbine consent, and these have actually led to large areas being no longer suitable for development. So that's a key. Yeah, definitely, I would recommend a good early look to see what has been built since the original consent. And just as a general rule, for large scale turbines, we would ideally want to see distances of at least 750, but ideally at least a kilometer from dwellings. So you can see how that limits the options on this site. So here's one of the options we looked at here was installing 6 reconditioned 2 megawatt turbines, which as you can see was tight when we also consider recommended turbine to turbine separations to limit the levels of internal weight losses. In addition, it was impossible to achieve the recommended setback from the transmission pylon that runs through the site. The safety guidance in relation to proximity from pylons has evolved over the years, and although the existing turbines are much closer than the current guidance would allow, we fully expect national grid and or transmission operators to dig their heels in about any changes of turbines going forward and ensuring that we adhere to the recommended setbacks, which may be very difficult for this site. And then finally, we looked at the option of using a modern large-scale turbine. We can see that with the preferred minimum residential setbacks, we were pushed to the edge of the site, and to secure a comparable capacity to what was already installed, a higher risk location out with the original land ownership had to be considered, which would need to have some detailed discussions around the future occupancy of the dwelling in question, and or moving that third turbine in the northwest to an alternative suitable location. Finally, an issue that's come up on a number of sites, which I know that Ewan is touching on as well, is aviation. When early wind farms were getting consented, the civil and or military aviation picture was very different to what it is now. And over the years, it's certainly become more challenging to get projects past these consultees. For some repowering projects, we've successfully argued acceptability where the existing project was already visible to radar. However, it is much more challenging where the original development was not tall enough to be visible to radar, but the proposed larger repowering turbine options are now visible. And that's certainly, again, a key consultee to run through and approach early on. So moving on to access, basically, well, with UK's smaller rural roads and the considerable increases in dimensions of turbine components, access is a key issue for not all new onshore wind developments. Even with existing wind farm infrastructure in place, you can see that it is still it's still problematic. And you can see that in the top right, the original an original wind farm site entrance, where there was 30-meter blades being utilized, being installed previously, and looking at the extent of issues in third-party land requirements when you're trying to bring bigger blades to site. So, and this is an issue for all wind farms, and it's no different for repowering sites. Alternative options include having blades arrive in sections, which some manufacturers offer, although somewhat disappointingly, the big bit of the blade is still typically over 50 meters in length, which from an engineering perspective is understandable in terms of the loads, but doesn't help us too much when it comes to getting easy access to the site for abnormal loads. And in addition, by going with sort of blades and parts, there is a need for final assembly on the site, which can come with significant additional costs. Increasingly, people are looking at blade lifting or scissor lift vehicles. However, if, like me, you've been kept tabs on the ongoing construction at Pineburn Wind Farm down in the Borders, you can see that these doesn't always go to plan, and I know they've had significant delays in getting the blades through Hoik, which I'm sure has ended up being a significant additional cost in terms of delays and higher cost of these blade lifting trailers. So yeah, it's sort of it's definitely something that we're well aware of, and something that needs to be fully assessed. Moving on to property, as discussed just before, it may well be the case that in addition to the existing legal agreements for the lease and any previous access leases, there may be additional agreements required with new landowners to allow for delivery of larger abnormal loads. I would, however, say that a key discussion is with the incumbent landlord. And from our experience, it's absolutely vital to have good open discussions as soon as possible about repowering opportunities. Generally, 20 years of dealing with one another may have led to some strained relationships between wind farm owners and their tenants. It's also fair to say that we've often seen landowners having different ideas than the wind farm owners as to what to do next. Not least because they may have had 20 years of wind turbine rental in their pocket, which obviously puts them in quite a strong financial position. Leases in the early 2000s were also perhaps not quite the ironclad behemoths that we generally see today. So I think you'll be doing very well if there are clear provisions in the original lease for extending or renewing the lease with a repowering option. And the key issue that we see is that original rental agreements were not as generous as they are now, and several landowners have had their heads turned by new developers that may have been offering significantly higher amounts. And this can be a cause for further friction if they feel that they were hard done by originally when in reality, the market has just changed considerably in the last 20 years. And things based on the last slide could be looking bleak for the incumbent developer. But the one saving grace that existing owners will have is they are very likely to be the party holding the connection agreement for the site. We've discussed both with SHEP-D and SPEN about the contractual position around this. And they have stated that the customer holding the connection agreement would be required, would need to novate it over to a third party if there was going to be anyone else other than them using the existing contracted capacity going forward. So that means otherwise on decommissioning of the original project, the capacity would in effect go back to the DNO, and any new project looking to develop on that site would be waiting for capacity at the back of the queue. So that basically means if unless there are other arrangements already in place, it's kind of critical that the existing project owner and landowner come to a mutual agreement on repowering of the site going forward. Otherwise, we're going to see a good amount, I think, of existing capacity getting given back to the DNOs because of a divergence in views and different plans going forward between the landowner, the existing developer, and any new developer maybe in the picture. And we've already seen this on a couple of sites where there has been an impasse and a going of separate ways, which is really unfortunate to see, given that basically meant that the site is only really due for decommissioning and closure. So in conclusion, repowering is an area where we are seeing a huge amount of interest at this time, and we see it as a really good opportunity for the reasons set out. Plans to increase capacity and or co-locate technologies to optimize the use of the existing grid may, however, result in significant delays in connection for any changes from the existing status quo, so need to be carefully considered. And as shown in this brief overview, available space, transport, and property positions available space and transport will dictate the achievable scale of repowering and result in additional planning, property, and commercial works that would certainly benefit from early identification while differing options are being considered. So I will now, if you hang on with me 1 second, I will pass over to Ewan, and actually a reasonably good time. So Ewan, hopefully that's you for now.
I'll just, yeah, okay, thanks, Ian. And on time, even better. So just onto the planning part of this. The purpose of this is not to go through each and every sort of planning scenario you might come across, but to try and kind of cover some of the main headlines and some of the things that we've encountered along the way in dealing with repowering proposals. Sorry.
Do you want me to click it?
Yeah, you click it and it's not transferring.
There you go.
So just picking up policy, first of all, I think we're in a fairly fortunate position in Scotland that we now have NPF4 in place, and it provides a reasonably supportive policy framework, not only for wind generation in general, but for repowering in particular. This hasn't sort of happened overnight. A lot of this goes back to the SPP, particularly with the areas being suitable in perpetuity. And a lot of work has gone in behind the scenes to ensure that the policy wording that's in NPF4 says what we want it to say, and that it is supportive of the wind development going forward, but as I say, repowering in particular. So that kind of sets a good foundation for us here, and really puts us kind of ahead of the game, particularly down south where they've got kind of 10 years of catch up to play on some of this stuff. Next one, Ian. So having established the sort of policy, just to make people aware, if you're not already, so that back in 2018, SNH, as they were at the time, produced draft guidance on repowering wind farms with the suggestion there that the baseline for EIA goes back to the restored site, not the current baseline, not the existing site as it is with a wind farm in place. Now that was challenged successfully, going back to the regulations themselves, which require that the current state of the environment is in fact the baseline, not what might then happen beyond. So I think that was another fairly sort of major battle that was fought out, which has laid a better foundation again for us going forward and how we deal with these things. It's established that as a sort of a founding principle. Next one, Ian. And I think if we take those two together, then and assume that the baseline is existing, then we're not going back to scratch. We're not going back to first principles. Instead, the assessments that we undertake for repowered sites can focus on the gap between the existing and the proposed. In some cases, that might be fairly minor. In other cases, it might be more significant. But it is nevertheless that sort of gap analysis. And I would suggest that anyone involved in repowering where any other suggestion is put forward should push back on that quite firmly. I think if you follow that route, then it's possible for the submission of a repowering application to be proportionate. The amount of assessment work that needs done is less than starting from scratch. And I think the opportunities to challenge that proposal are less than you would expect starting with a greenfield solution. But as ever, these things are best agreed in advance. Don't take them for granted. We have seen incidences where there is still pushback. So yeah, get in early, have those discussions with the planning authority and other consultees, and agree a sort of proportionate and practical scope going forward. Yeah, next. So just in terms of some of the other changes that have come along in the meantime, going back 20, 25 years, there's a number of strategic designations that will have potentially emerged over the lifetime of your existing wind farm, potentially the two existing national parks, but certainly wild land areas. Down here in Dumfries and Galloway, we've just recently been woken up to the prospect of a new Galloway National Park looming over the horizon. That's on top of Eskdale Muir, which takes up the eastern part of Dumfries and Galloway, and you have other things like the flow country up in the Highlands. So these all kind of just introduce additional strategic changes, be them on a technical or a political level. And whether those are real or not, they may pose limitations or additional hurdles, which you need to overcome, which maybe wasn't the case the first time around. Okay, next one. Coming back down to sort of the site specifics, and looking at buffers, particularly around designations. Again, we've managed to sort of push back on the notion here in Scotland that there should be any sort of buffer zone around designated areas. That was established in the old SPP, and whilst it hasn't been translated entirely into MPF4, there's still that principle is still established in relation to wild land areas. But again, having been involved recently in a repowering project down in England, there's still this sort of looking out from within designated areas into the undesignated areas beyond. And I think, again, that's something that we can push back on up here, and need to start pushing back on down in England. In terms of even more site-specific ecology buffers, one thing to watch out for is just setback distances for bats. The whole sort of analysis and assessment of bats has moved on significantly in the last 20 years. Turbines that were maybe set with a minimum distance back from field boundaries or forest edges, if you're looking to repower those with bigger machines, then that buffer will increase. So either you have to move, and this tends to be for kind of smaller turbine projects, but you're either going to have to move the turbine out more into the middle of the field, or cut back into the trees and the hedgerows round about, which will involve then replacement and replanting. Next one, Ian. Ian mentioned earlier aviation, and particularly kind of radar visibility. Obviously, a larger turbine, if a smaller turbine was designed specifically to avoid radar visibility, then a larger turbine runs a risk of being visible to radar. It might be something that wasn't even considered previously, but if you are going for larger turbines, then there is that risk. It's not to say there aren't solutions, but again, particularly for smaller projects, those solutions can be costly. And if you're not part of a larger strategic response to those situations, then that can be prohibitive. So overall, it can be a significant limitation on repowering options. Next one, Ian. Just one additional issue on aviation is aviation lighting. CAA regulations state that if you're above, for structures above 150 metres, then you need to have visible aviation lighting, as opposed to infrared or whatever may have been the case on smaller turbines. But there's lighting and there's lighting. This is the slide here shows an example of the type of lighting that can be used, and it's specifically designed for this purpose. There was a lot of fear, scaremongering, whatever you like, sort of drummed up when this first became an issue, that we were lighting up the dark sky and so on with these lights. In actual fact, these lights are, as you can see by the design, they're specifically designed to have a very narrow band of visibility, and they don't shine up, they don't shine down, they shine outwards towards to enable approaching pilots to see the light, and that's their sole intention. It's not to shine down on the ground or up into the air. So if you put this in a room, you would get a very narrow band of light going around the room. So that, it's important to be aware of that, because again, there is still a lot of uncertainty and a lot of misunderstanding about these lights. They will more likely require additional levels of LVIA. You may require nighttime visuals or dawn and dusk visuals. It may give rise to additional objections because you're introducing a level of impact which wasn't there before, and at different times of day, when turbines previously would have been almost kind of invisible. At night, you're introducing an element of visibility, and quite often into sort of quiet or relatively dark rural areas. Your local authorities may not have experience or understanding of dealing with these, so there's a kind of education piece to go through there. And if you want a case study of this, then look at the Crystal Rig 4. It was a Section 36 project between Scottish Borders and East Lothian. It's a Fred Olsen project from 3 or 4 years ago, where this entire issue was played out on a single issue public inquiry. We ended up acquiring one of these lights and using it as a kind of demonstrator, and and switched it on and off on top of a turbine so that the reporter could see for himself what the likely level of impact was going to be. And off the back of that, one of our colleagues here at Locogen, Jim Howitson, has been asked over the last couple of years to chair the Scottish Government Aviation Lighting Working Group, which is due to publish its guidance by the end of 2024. And that will hopefully set a kind of a baseline again for us all to be able to assess this impact going forward. Thanks, Graham. So just quickly to wrap up, policy in Scotland is generally supportive of repowering. There's been a lot of efforts gone into that over the years, and I think we're in a good position there. Baseline is the key, and the current position is the baseline. And if we follow that through, then assessments should hopefully be proportionate and focused on the degree of change, not going back to first principles. Changes may have happened in the meantime. They can be strategic and or localised, and it's important to sort of be aware of those changes and the extent and impact of those changes in the design and the assessment of our repowering projects. And that's me.